Hello, everyone. Ian Hamilton here with Good Virtual Reality, and thanks for giving me your time today. You can become a member at goodvirtualreality.com and also support independent VR journalism directly with a donation. Today, I'm joined by Dr. Bobby Korn, who has written an intriguing paper about the use of Apple Vision Pro in medical settings. Hello, Dr. Korn. Can you say where you're tuning in from today and give us a little bit of background about yourself?
Ian, thank you for the invitation here. I'm Bobby Korn. I'm an ophthalmologist, as you mentioned, at UC San Diego, and I'm calling and speaking to you here from San Diego, California.
So let's talk about this paper here. Can you sum it up for our audience here? What did you test and what was the exploration here?
Great. Well, let me step back and sort of give it to you in sort of lay terms, because really maybe most of your crowd is non-ophthalmologists and non-oculoplastic surgeons. So the problem that I'm treating my patient here is a blocked tear duct. And, tears drain through a normal drainage system. And when it can become blocked, it can not only impair your vision because of all the water that overflows onto the eye surface, but it can actually become infected and cause an infection that spreads to your eye and potentially losing vision. So the way we treat this problem is really to create a bypass drain so the tears can drain naturally into the nose. And the way we approached it hundreds of years ago was to externally do this by making a skin incision. Now, with the recent advent of endoscopes, these tiny cameras that we can place through really small orifices, we can actually do this through these small screens. And so I do this operation that is called a dacryocystorhinoscopy. We abbreviate it DCR, and we actually do it endoscopically. So what I do is I use a small endoscope. It's typically 4 millimeters in diameter. I look through the nose, and I do all my surgery there. And I've been doing this for 25 years using a traditional endoscope. The endoscope is then connected to a monitor that sits a few feet away from us in the operating room. What we did with Apple Vision Pro was we really asked the question, can we actually make the operation more efficient for the patient and the surgeon by actually moving the screen from like a tower-mounted screen right in front of us, in the headset. So that's really where it began. The way we designed the study was really to make a very simple comparison. What is the operation like using a traditional endoscope, using a tower monitor's mounted screen, or using the Apple Vision Pro?
Got it. And so what did you find? What were the conclusions here? What are the takeaways?
Well, the first thing that we have to do is we have to make sure that we do a study like this in a very ethical and safe manner. So to do that, we used what's called an institutional review board or an IRB. So any study that is done really needs to place the safety of our patients first. And so under the guidance of an IRB, we performed a study where we compared, monitor versus Apple Vision Pro. And we looked at a couple different things. The first thing was how effective was the operation? And this operation is normally 93% effective. So it's already a very effective operation to begin with. But what we found in our cases here, compared to using just a traditional monitor-based tower and the Vision Pro, they were both 100% successful. That was the first thing. So we knew that it was an effective operation. The next thing we did was we asked a really simple question. Was the surgery faster or the same, or did it take longer using the Apple Vision Pro? So the way we did that was that we actually went into the electronic medical record system. Our nurses are constantly charting and collecting all the timing of our procedures. And we compared these two. And it turns out that using the Apple Vision Pro was actually 8 minutes quicker doing the operation compared to using just a traditional monitor that we're looking at across the room here. Corollary on top of that was we also then asked a really simple question to the surgeons doing the operation. Was it any different from you from a workload standpoint? And we used a study or an index called the NASA TLX study, which basically measures the workload, how difficult it is to do something cognitively. We actually found that for all the surgeons, it actually reduced the workload using the Vision Pro compared to using a traditional monitor.
So the one part of this that I really wanted to focus in on was the time savings. And I wanted to understand how that equates to money savings. There was some language that sort of said, this is just an initial study. You can't really make a whole lot of conclusions from these rates. But when you start adding up a few minutes saved per operation, it ends up being something on the order of like $50,000 a year in savings per physician. Did I read that part of the paper correctly? And can you sort of walk me through? Are we literally talking about the cost of turning your head as a physician?
And that's a great point. And, it's a really interesting way of thinking about that. When you pose it like that, you're really asking, what is the cost of turning your head, right? I think you can look at it from multiple verticals. I mean, certainly there's the cost savings, which I'm going to get into, but there's also the benefit for the physician and the surgeon itself. So let me be a little self-centered and focus on the physician side first. Then I want to get into the cost side. When you're actually looking at a monitor, you're actually oftentimes using one monitor that is shared by everyone in the entire room. So it's not naturally the most ergonomic thing that you're using. So you're turning your head, you're turning your hips, and you're doing this hundreds of times throughout the case. And that creates a significant amount of fatigue for the surgeon themselves. What ends up happening is that when I'm doing work in the nose, taking instruments in and out, I'm actually doing this hundreds of times during the case. And as I look down and I look up, my eyes are constantly looking for the image on the screen. With the Vision Pro, the image is always in front of us. We always see it. And so we're not actually doing the surgery any faster, but we're more efficient. We're not wasting any time. So the signal to noise ratio, if you think about it that way, is really improved and optimized. And so that really results in about 8 minutes saved. And the efficacy is the same here. It's 100% success. So what does that 8 minutes really correlate to? You've heard the expression time is money. And when we think about healthcare costs, healthcare is about 25% of the federal budget, and about 20% of all the spending, or at least the GDP in this economy, is actually dedicated to healthcare spending. So basically, $1 in $5 is spent on healthcare. And so we did a really rough calculation to see what it really cost or what the savings were from turning our head and being more efficient with our actions. On previous studies has actually showed that a 1 minute of operating room time is around $51. That's savings for the equipment in the room, the staff in the room, the medications used. I mean, there's just the electricity in the room. Everything is more expensive in healthcare. And so if you average that per case, it's around $420. And then if you extrapolate that to a single surgeon doing, 100 of these operations a year, that could be $40,000 to $80,000 saved. And then you extrapolate this across the country, not just for this operation, but for every endoscopic operation that is performed. I mean, this adds to a significant amount. So it's really not just a cheaper equipment issue where, of course, the Vision Pro is more cost efficient, but it's actually just the global healthcare savings that are resulting. And then that's added on the fact that the operation causes less injury to the physicians. There's less physicians that are leaving medicine completely because of neck strain and neck pain. There's just so many positives that really come out of this study here.
Fascinating. All right. So this is great time to bring up the context of my previous podcast where I talked to a company called HMD MD, and they make a very low weight head-mounted display with sort of an open periphery so the physician can look around and see their surroundings. And they've got very high-resolution microdisplays right in front of the eyes to provide on those microdisplays the imagery from the camera that's inside the human body. A lot of similarities to what you're doing. And when I was talking to the CEO there of that company, they mentioned that their big benefit or one of the areas that they focus on is stereoscopic cameras. The analogy there is that the doctor is looking at a 3D display and they've got sort of 3D glasses on. And there's certain procedures where it helps to have stereoscopy added. What are those procedures where stereoscopy matters?
We're looking in the nose through a 4 millimeter scope. We really don't need to have really high fidelity stereopsis in our view. And that's partly limited to the fact that we're working in a very small and narrow space. Now, say you're working in the brain, say you're working in the abdomen where you're doing surgery on a larger scale, you have the ability to add larger endoscopes, which, can have a left and right sided mounted camera, so you can get stereopsis. That could potentially have benefits. GI surgery, brain surgery, and actually, interestingly, intraocular surgery inside of the eye when you're actually doing, say, cataract surgery vascular surgery on the retina, where tissues are literally the thickness of microns of sheets of paper. I think those areas are really, like ripe for disruption for this. And so the thing I really looked for was, using, because I've tried several different headsets and different VR mounted systems in the past. And there was just so many limitations. Partly it was the latency, the refresh rate, where the images were projected, the ability to even look at an image for a long period of time and not get eye fatigue, was really important. So, the things that really drew me to Apple's device was that, the resolution is just so high and so crisp. The refresh rate is good. But in addition to that, though, is the pass through. So you mentioned that other system where you actually place it over your eye and you're able to look in the periphery. Every time you do that, your eye has to undergo a process called accommodation, where you actually change the shape of your eye and the lens to bring things up close and far away. And that just adds to the fatigue and exhaustion to a surgeon if they're, say, doing an operation for several hours at a time. So I think, you want a surgeon who's comfortable, who can see exceedingly well with the image that's presented into them, really to give you the best outcome. So stereopsis has its role. And you will see, I think, more platforms as things become more miniaturized and micro-sized, better quality, better fidelity. But for our study here, it really wasn't necessary. It really didn't change the outcomes, of what we did. But I know my colleagues are using stereopsis with endoscopes already, using Vision Pro and other platforms.
Interesting. Fascinating there. Very, very fascinating. A lot of my listeners will be familiar with the Vergence accommodation conflict that is sort of inherent to HMD use. It's absolutely fascinating to hear this is almost like the flip side of this, that actually keeping the person inside the headset and keeping them fully enclosed keeps them from having to refocus their eyes, looking around at their surroundings. Fascinating, fascinating stuff here to think about the potential benefits there of keeping a person focused on that display that's in front of them. And if they're looking at the pass through, keeping their eyes focused at the same focal distance. Going back to the study, what are you most curious about now? What do you want to see revealed in future follow-ups?
Sure. So there's several different things that we're looking at. First of all, I think it's to really get this to more mainstream use, we need to expand it to other centers. Our study looked at 16 patients in each group. So it was a small focus group. But I think when you look at this across the country with hundreds of cases, this gives you more validity in the use cases. And ultimately, what we want to do is we want this to be available to everyone. I'm at a university. I have an institutional review board where I can do these studies ethically and safely for patients. But what we need ultimately regulatory approval. And I think the pathway going for this is to really have a software solution that allows us to visualize these operations through the Vision Pro. And once that's available, you can use this anywhere in the US. If you think about this, I do a lot of work, mission work in other countries where they don't have up-to-the-date cutting-edge equipment available. I could literally put an Apple Vision Pro into my luggage, bring an endoscope, and I can do this operation anywhere in the world. And so just, democratizing this care and this technology can really benefit patients all throughout the world. So I think one, getting approval from the FDA from a software standpoint to really allow us to visualize our operations on the Apple Vision Pro is probably for me the number one next step that needs to be solved. And once this is solved, you'll see mainstream adoption all throughout the country.
Fascinating. I'm also curious about weight loss related to the headset. It's still a pretty heavy device. All the current VR headsets are extremely heavy. That's why the HMD MD was so interesting to me, as I wanted to understand the stereopsis, but also I wanted to understand what does a really lightweight device do in comparison to these big bulky VR headsets that we have now. But I do believe we're at the cusp of an entirely new generation of these head-mounted displays. It appears that the market is taking a note from Apple's decision to put a bunch of components in a pack that you wear on your side. Meta here just spent a decade building head-mounted displays where almost all of the weight is contained on the front of your head, sort of weighing down your neck. And a lot of people get really annoyed by that strain. And when you're talking about doctors using this for 8 hours or more in a day, that would add up as significant strain. So I believe we're at the cusp of a new generation of these devices that have all the benefits that you currently observed and tested with the Vision Pro, the quality of that display, but also the weight loss is going to be profound. I think we're talking hundreds of grams of difference of being weight on the front of your head as early as next year in new head mounted displays. How significant would having a few hundred grams less on the front of your face be for this whole research?
The one of the first, I think, things that when you read about the Vision Pro initially is the weight. You're wearing this heavy sort of headset on the front of your head. One of the biggest game changers for me was using this new head strap that Apple just released called, I think it's the dual knit head strap. And when you actually place it on your headset, it's actually heavy, but it's actually amazing what it does. Because, Apple, when they hear about something, they always try to innovate and improve and listen to their customers. And so we complained to Apple, it's like, it's too heavy in the front. We need something to counterweight it. So this dual knit headband actually has weight within the strap itself. So it actually counterweights the front and back side of the headset. So you really get a neutral positioning of a weight on your neck. I thought to myself, can I wear this all day long? You don't even think about it because your whole body is relaxed, your shoulders are relaxed, your hips are relaxed, all your muscles are relaxed. So it's almost just like wearing like a heavy baseball cap on top. Most of the time when we're operating, if we're operating in small spaces, we're already wearing a headlight that is already mounted to our head. So we're used to that weight on our head. As with anything in technology, it's going to get faster, better, lighter. I view my role here is, as an early adopter. I've always been an early adopter of technology, is to really push the envelope and allow us to develop the framework, the software, the workflow to really help us do this so that future generations can benefit from the better technology. So I'm excited. I'm sure if I were to look into my office in 5 years, I'll see a whole line of different generations of headsets and sort of reflect on how the evolution of the technology. But I'm excited. I don't think, spatial computing is going anywhere. I think the field is only going to get better, and it's going to really make the experience better for surgeons and ultimately patients and the healthcare system.
Very fascinating to hear you used the dual knit band in these procedures. That is sort of the very latest sort of tech that Apple has released here for its systems. Did you also have prescription lenses in there? Do you require prescription lenses? Did you need that?
Absolutely. I've used the other Meta devices. For those, I had to, put my glasses on within the headset itself, which added a little bit more to the bulk. But the nice thing about the Vision Pro, as you mentioned, Ian, is that you get these custom made Zeiss optical inserts. And I'm myopic. I have difficulty seeing far away. So I have very specific prescription inserts for my Vision Pro. And it allows me to see beautifully. And the nice thing about this device, as we talked about earlier, is that the image is actually projected at distance, not up close. You're not getting the eye strain of bringing an image really close up and accommodating because it's actually projected at distance. So, I mean, it's a win-win situation there.
Amazing. Is there anything else you want people to know about your work and where this is going?
We're just excited that, people like yourself, Ian, are paying attention. We really care about our patients. We really care about, using the best innovations and technology to improve the outcomes for our patients. For us, this is really not work. We love doing this. We love seeing the experience on our trainees, our next generation. And, in an academic institution where we are, we train the next generation of physicians. So partly it could be self-serving because I want these young doctors to one day use this technology. When I need it, it'll be available for them. And I'll know that the benefits are better for myself as the patient and for the surgeon itself. So I'm excited to see where this is going. I hope more clinicians use this, more surgeons try this and employ it in their clinical practice.
Amazing. Thank you for the time. I would love to follow up with you in the future. If you hear of any other researchers testing this out, any other physicians sort of going down this path, looking to replicate your work and test this for themselves or expand this research, please feel free to pass along my contact information and we'll stay on this story and make sure we follow up in the future. Thank you for the time.
Thanks, Ian, for bringing it to our attention. Have a great day.